Okay, this is the video for the November 3rd class that we're not having class, so I'm going to go over a couple of integration by parts just to give you some help for your homework. I think there's 5 or 6 problems. The first one we're going to do the antiderivative of x times e to the 2x dx. Now we're going to pick a u and a du. A u and a dv. I'm going to make u equal to x. We'll have to take the derivative, and dv is equal to e to the 2x, and we'll take the antiderivative. Du is equal 1 dx, and v is equal to e to the 2x over 2. Derivative of 2x is 2. So that's how we do that. So ultraviolet minus voodoo. So u is x, v is e to the 2x over 2, minus the antiderivative of v, e to the 2x over 2 dx. And at this point you see that the u du portion starts to cancel out, and you're left with the antiderivative of dx, which is 1. So you can rewrite this, bring the 1/2 out front. That's going to be 1/2 x e to the 2x minus 1/2 antiderivative e to the 2x dx, and 1/2 x e to the 2x minus 1/2 antiderivative e to the 2x is e to the 2x over 2 plus c. Now at this point, this is the basic answer. You can manipulate it. You can factor out a 1/2 e to the 2x. You can factor out an e to the 2x and leave the fractions intact, but that's basically integration by parts. Okay, so let's try another one. Same type problem. Antiderivative of x e to the negative 4x dx. I'm going to make u equal to x, so we're going to have to get du. And v is equal to e to the negative 4x, and we're going to find, dv, and we're going to find v. So that would be dx. Derivative of x is dx. The antiderivative of e to the negative 4x is e to the negative 4x over negative 4. Ultraviolet minus voodoo. Oops, I don't know why I did that. Ultraviolet minus voodoo. So ultraviolet is x, all this, minus the antiderivative of e to the negative 4x over 4 dx. Go ahead and pull everything you can out. Negative 1/4 x e to the negative 4x. I just brought this 1/4. I brought it out. There's a 1 out here. 1 over negative 4. I brought it out. Minus 1/4 antiderivative of e to the negative 4x dx. Negative 1/4. You can see this. There we go. Negative 1/4 x e to the negative 4x minus 1/4 e to the negative 4x over negative 4 plus c. And that negative 4 and that negative 1/4 comes out to be 1/16. And again, this is the basic solution. and you can factor out a negative 1/4 e to the negative 4x, and that'll leave you with x plus 1/4 plus c. Okay. Like I say, once you get it down to a method, that's pretty much it. Very methodical. Antiderivative of x to the 4th, natural log of x dx. And then that's going to give us u is equal to natural log of x. Du is equal to 1 over x dx. dv is equal to x to the 4th dx. v is equal to x to the 5th over 5. Ultraviolet minus voodoo. So natural log of x times x to the 5th over 5 minus x to the 5th over 5 times dx. 1/5 x to the 5th natural log of x minus 1/5 antiderivative of x to the 5th dx. 1/5 x to the 5th natural log of x minus 1/25 x to the 6th. I'm sorry. I think I messed up. Be x to the 6th over 6, which would be the 30th. My mistake. Plus c. And here you can factor out a 1/5. And that would be 1/5. That's about all. X to the 5th. And then that would give you natural log of x minus 1/6 x plus c. But again, the basic solution is all I'm looking for. Make sure you can do the mechanics. Now the last one, I'm just going to show you, we did one like this in class, but I want you to go over it again. You might want to have to turn the paper to the side a little bit, because this one that takes a little bit of paper. So the antiderivative of e to the 2 theta sine of 3 theta. I'm not doing theta. That's just a pain. Redo it. E to the 2x sine 3x dx. Okay. U is equal to e to the 2x. Du is equal to 2e to the 2x dx. dv is equal to the sine of 3x dx. V is equal to negative cosine of 3x over 3. So ultraviolet minus voodoo. I'm going to write it over here because this is the problem that we did in class where you actually have to algebraically solve. So I'm going to put this in red because we're going to keep it e to the 2x sine of 3x dx. I'm going to keep that on the left hand side. E to the 2x sine of 3x dx is equal to ultraviolet minus voodoo. So u e to the x, I'm sorry, e to the 2x, v is negative 1/3 cosine of 3x minus voodoo, which is going to be negative 1/3 cosine of 3x times 2x, 2e to the 2x dx. So we still got our red one over here. Is equal to, well, that negative 1/3 can come out. E to the 2x cosine of 3x. That 1/3 and that 2 can come out, and that negative makes this a positive, so that's going to be positive. 1/3 times 2 is 2/3. Antiderivative of, and I'm just going to bring that e to the 2x back over here in front, cosine of 3x dx. So we got to do ultraviolet minus voodoo again, and I'm going to make u equal to e to the 2x. du is equal to 2e to the 2x. dv is equal to cosine of 3x dx. And v is equal to, the antiderivative of the cosine is the sine, so that's going to be 1/3 sine of 3x. So absolute value. Antiderivative of 2x, e to the 2x sine of 3x dx is equal to negative 1/3 e to the 2x cosine of 3x plus 2/3, and then ultraviolet minus voodoo, e to the 2x, I'm going to put this in brackets, e to the 2x ultraviolet 1/3 sine of 3x minus antiderivative of 1/3 sine of 3x 2e to the 2x. Okay, I know you can't see that, but just use your imagination, and of course there's a bracket there too. Our red is still here. Is equal to negative 1/3 e to the 2x cosine of 3x plus, and we're going to leave that 2/3, we distribute it, 2/3 times 1/3, I think that's 1/3, isn't it? Yeah, 1/3, yeah. 1/3 is 2 over 9, e to the 2x sine of 3x. That 2 and that 1/3 can come out, and that'll be 2/3 times this 2/3, which would be 4/9. Antiderivative e to the 2x sine of 3x. Now I just want to take another pen. I'm going to take this bright green. Remember, this 2/3 has got to be distributed here with this 1/3, and that gives you 2/9. And then distributed with that 2/3, and then it's also distributed right here and multiplied by this 1/3 and this 2. 2 times 1/3 is 2/3. 2/3 times 2/3 is 4/9. So that's just to give you a little bit of insight there. Now I'm going to take another color, like this orange, and I want you to look at and what does that orange look like? Well, the orange looks like the red. Now, as we talked about in class, sometimes you're going to be doing the the integration by parts, and you're going to find yourself in a loop. You're just going to keep on going and keep on going, and you're never going to integrate that right there, because it's always going to be e to the 2x times the trig function. You're never going to dissipate, you're never going to get rid of one of those terms. It's always going to be integration by parts over and over and over and over again. If you find yourself in that loop, then you need to go back and find something that's identical to this, to the red. And there it is. So I'm going to bring that over, and that's going to be, and this is a 1, so that's going to be 1, I'm going to do it in red, e to the 2x sine of 3x dx. And then I'm going to bring this negative 4/9 blah 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 over here, and it's going to make it positive 4/9 antiderivative of e to the 2x sine of 3x. And you see, this is combining like terms. I should have used a different color, but this is red and this is orange. That orange comes over here across the equal sign, so it makes it a positive. And these two, this is 1 times the square root x plus 2 plus 2 times the square root x plus 2. So these two are the same. They're the same sign, the same label, so you can combine them. And since that is gone, we can kind of cross that out, and you're left with just this right here. And that's going to be negative 1/3 e to the 2x cosine of 3x plus 2/9 e to the 2x sine of 3x. And your final answer, I'm going to take the red and I'm going to turn this 1 into 9/9. 9/9 plus 4/9 is 13/9 antiderivative of e to the 2x sine of 3x dx is equal to all of this. Negative 1/3 e to the 2x cosine of 3x plus 2/9 e to the 2x sine of 3x, and I'm going to go ahead and put a plus c out here. And this 13/9, to get rid of the 13/9, you multiply by 9/3. So I'm going to take a purple marker, which is not going to help very much, but I'm going to multiply this by 9/13. That does away with that. So now your antiderivative is equal to all of this. Okay, now that is what we have started. We started that, started some of these, started the basic ones, and you have homework for attendance, and you also have about 6 or 8 problems of homework for integration by parts. And I will see you next Thursday.